Hi folks, this is question 5. So we just have to find the derivative here first of all. So it's 1 over 5x squared plus 7. So get rid of that for a second. So you can rewrite that as 5x squared plus 7 to the power of minus 1. And then it's just using the chain rule. So f dash x will be, so reduce down the power, multiply by the power first, so it's minus 1 multiplied by 5x squared plus 7, then reduce down the power, so minus 1 goes back to minus 2, and then you have to multiply that by the derivative of what's inside, inside the bracket, so that's just chain rule, so that will be 10x, so 2 times 5 is 10. You can simplify it a little bit, so you've got 10x over and then 5x squared plus 7 squared, and that's it. You don't need to multiply out the squared on the bottom or anything. Right, next one, and this is just product rule really, and then you have to put in the pi over 2 at the end in for x. It's a little bit complicated. So product rule anyway. We'll call this u and we'll call this v. So u dv dx plus v du dx. So it's just tan x over 2, then the derivative of this, the v here, should be a v. So derivative of natural log x is 1 over, so it's just 1 over x. And then you're adding on, so it's just natural log x then, and then you're multiplying by the derivative of u. So the derivative of u here, it gets a little bit complicated. Derivative of tan anyway is 1 over cos squared. So it'll be 1 over cos squared x. But then because you actually have to do chain rule here as well, because it's a function within a function, it's the x over 2 is inside the tan thing. So you have to multiply that by the derivative, but that's it's going to be 1 over 2. Derivative of x over 2 would be 1 over 2 because it's 1 over 2x. Okay, then you have to just put in, can we simplify this a little bit? Not really. We just have to put in pi over 2 everywhere there's an x. If you put pi over 2 in instead of x, so it'll be tan, and it'll be tan of pi over 4. And the reason is because if you put in pi over 4 all over 2, that's the same as over 2 over 1, so you flip, it's dividing fractions. You could do it in the calculator if you're not sure, but it's the same as pi over 4 multiplied by 1 over 2, which is the same as pi over 4. So you get pi over 4 when you put it in there anyway. Multiplied by, and it's, so 1 over pi over 4 will end up being 4 over pi. And then plus ln pi over 4, just go straight in. 1 over cos squared pi over 4, and then that's just a half on the end. Now actually that should be a 2 in there, because we're just putting it straight in for x. Now we end up getting a half here, 4 over pi plus, and then so you need calculator, obviously you need to 1 over cos squared pi over 4, and so we end up getting well, ln pi over 2, that's just there as normal. A half is still there. The 1 over cos squared pi over 4, then that should simplify down into 1 actually. Is that right? No, 2, sorry. Yeah, that should simplify down into 2. So the 2 and a half actually cancel out. So you're left with the 4 and the 2 will cancel, so you end up with 2 over pi plus, and it's just going to be ln pi over 2, and you can't go any further than that. Then that should be in the form that they wanted it in. Yeah. Right, part C then. Part C, another unusual question here. So, well, not unusual, but it's just something that would have been unexpected. Find the value of g of f of 3. This is actually quite easy. So you just have to find f of 3 first, and then whatever that is, you go on and you do the function g with it. Okay, so if you do f of 3 first, you're starting on 3 here, and you're just using the function, so you're getting to, and that's a little earth symbol there. So so you get to earth, and then once you've done that, so you've done that function, you've done f of 3, then you need to do g of that. So you just need to, so all you're doing is just going on further, you're just going on with the other arrow, and you just get to w. So w is the answer there. You can't really show much workings. You could show 3 goes to earth and onto w, something like that. W is the answer. But it may have confused people. The next bit is injective and surjective. So you have to decide, or we'll have to explain why B to C is injective but not surjective. So I just googled quickly the exact definitions of, so you need to know what injective and surjective mean, obviously, and a lot of people wouldn't, you might have focused that much on your revision on this. So an injective function is one in which each element of y is transferred to at most one element of x, okay? And that does happen here from B to C. So every element in B goes to at most one element in C. So that's true. So okay, so something like that is all you need to put down there. It's not surjective, so we have to look at why it's not surjective. So surjective is a function that maps each element of y to some at least one element of x. So that's not true then for this. So the reason is because of the y. Okay, so every element in B would need to go to an element in C, but nothing from B goes to C. So so each element of y to some element of x. So everything must go to some element of x. So here in our one, everything must go to some element of C. Okay, but it doesn't, because nothing goes to y. So because nothing goes to y. Okay. And then that's it. That's all for that question.